Hi everyone, video solution to two questions that appeared as part of the sample paper given by the CBSE Board for term 2 of academic year 21-22, standard version of the paper. Both these questions are from the chapter circles. One is a section A question, the other question is a section C question which has got an internal choice. Interesting questions. Let's get started. What we'll do is, as we read the information, we'll try and quickly draw a diagram, see what is asked of us, and then actually see it in a printed form subsequently. From a point P, two tangents are drawn, right? This is point P. To a circle, we are able to draw two tangents. They said these two tangents are called A and B, PA, PB. So, AB are the points where these two tangents meet the circle. Center of the circle is at O and the radius of the circle is equal to R. So, this is given as R. So, OA equals OB is equal to R. OP is equal to 2R. The point from where the tangent is drawn to the center of the circle, the length is equal to 2R. What is the measure of angle APB? That is the first question. What kind of a triangle is APB, right? This triangle, what kind of a triangle is it? Step 1, let's first draw this diagram again in a printed form, understand some basics, establish some things, and then find out the angle APB, right? So, given triangle, given circle, from a point P, we have drawn two tangents. The distance between the tangent point where the tangent is drawn to the center of the circle is 2R. Radius of the circle is R, so which is also equal to OB, which is equal to R. You have to find out the measure of this angle, angle APB. Subsequently, we also need to find out what kind of a triangle is APB. We will come to that after finding this angle. It is necessary that we know the angle to be able to determine what kind of a triangle it is. So, let us establish a few things. First, we know that PA is a tangent, PB is also a tangent. So, both of these are tangents, and OA is radius, so is OB, OB is also radius, OB is radius. Therefore, few things we will establish. PA is perpendicular to OA and PB is perpendicular to OB. The radius and tangent are perpendicular to each other. So, this is equal to 90 degrees, so is this equal to 90 degrees. So, establish this is the first thing we have established. The second thing we are going to be establishing is the fact that by RHS, right, by RHS rule, right angle, hypotenuse and side. Look at it, we know the triangle OAP and OBP are both right angle triangles. OAP and OBP are right angle triangles. The side opposite to the 90 degrees is the hypotenuse, which is OP, which is common to both. And one of the perpendicular sides is OA in one triangle and OB in another triangle, which measures R. So, by RHS, we have established that these two triangles are congruent triangles. So, first we established that these two angles are 90 degrees. Subsequently, we established that these two triangles are congruent triangles. We have established that these two triangles are congruent triangles. By corresponding parts of congruent triangle, we can say that angle APO is equal to angle BPO. So, if I can call this angle to be equal to theta, this will also be equal to theta. So, what are we trying to find out? We are trying to find out angle APB, which is equal to 2 theta. Now, quickly let us take this information and see what we have. So, we know that this angle is equal to theta, we know this is a right triangle. So, we will find out angle theta. To angle theta, look at it, this side OA in right triangle is the opposite side. And we know OP is opposite to 90 degrees, so that is the hypotenuse. So, we know in terms of the radius, the lengths of the opposite side and the hypotenuse. So, which trigonometric ratio will we be using? We will be using sine. So, sine of angle theta is equal to the opposite side OA divided by the hypotenuse, which is equal to OP. So, this is equal to R by 2R, which is equal to 1 by 2. Sin theta is equal to 1 by 2, which means that theta is equal to 30 degrees. Theta is equal to 30 degrees. We have already established that this is also equal to theta, which is equal to 30 degrees. So, angle APB is equal to 30 degrees plus 30 degrees, which is equal to 60 degrees, right. So, we have found out angle APB, that is part 1, that is done. Part 2, we will have to find out what kind of a triangle is APB. We found this angle to be equal to 60 degrees. Now, we established these two triangles, right, triangle OAP and triangle OBP to be congruent triangles, which means PA is equal to PB. We otherwise also know that from an external point we'll be able to draw two tangents. Both these tangents are equal in length. Because PA is equal to PB, it's evident that angle PAB is equal to angle PBA, right? Both these angles are equal. So we'll call this angle to be equal to an alpha. We'll say this is equal to alpha. So in triangle PAB, the measure of the three angles are basically 60 plus alpha plus alpha. Sum of these three angles will be equal to 180 degrees. So 2 alpha is equal to 120 degrees, implies alpha is equal to 60 degrees. So alpha is 60, this alpha is also equal to 60. So look at the three angles in PAB. All three angles are 60 degrees, which means the triangle PAB is an equilateral triangle. So two things we needed to find out. The first one is angle PAB, as angle APB, which is equal to 60 degrees. Second one, what kind of a triangle it is? It's an equilateral triangle. Move on to the section C question. We are looking at the first internal choice of it. Prove that the angle between the two tangents drawn from an external point, right? From an external point, we are drawing two tangents to a circle. The angle between these two tangents, we'll call it as theta, is supplementary to the angle subtended by the line segment joining the points of contact to the center. These are the points of contact. This is the center. So the angle made by this line with the center, this angle is equal to 180 minus theta is what we need to prove. We need to prove, for example, if this is AB, we need to prove APB and AOB are supplementary angles. That's what we need to prove. Quickly look at it in the next diagram, right? Is everything clear till this point? What we need to prove? We need to prove that the angle between the two tangents and the angle subtended by the line joining the place where the tangents meet the circle with the center of the circle, which is this angle, angle AOB. We need to establish that these two angles are supplementary. First thing what I marked is what we are going to say. PA is a tangent, PB is a tangent, and it's very clear that OA and OB are radius. OA is radius and OB is also radius. Therefore, the first thing that we are going to establish is that PA is perpendicular to OA and PB is perpendicular to OB. So these two angles, you mark them as 90 degrees. That is done. Next, look at it. What is PAOB? PAOB is a quadrilateral. So in a quadrilateral, sum of the interior angles is equal to 360 degrees. So angle APB plus angle PAO plus angle PBO, right? This angle plus angle AOB. The sum of these four angles is equal to 360 degrees, right? Actually, I should have written AOB and then PBO when it comes in a cyclic order. We'll fill in the values properly, right? Angle APB is, we'll retain it as APB, right? Angle PAO is equal to 90 degrees plus angle AOB plus angle OBP, which is also equal to 90 degrees. This sum is equal to 360 degrees. 90 plus 90 is 180. Take it to the right hand side. That will leave us with angle APB plus angle AOB to be equal to 180 degrees. If sum of these two angles is equal to 180 degrees, these two angles are supplementary angles, right? So proved it. Property that we used is basically that the angle between the tangent and the radius is a right angle. Second one, sum of the interior angles of a quadrilateral is equal to 360 degrees. This question, as I mentioned, has an internal choice. This is the option that we have as a second option, right? Two tangents TP and TQ are drawn to a circle with center O from an external point T. So let's quickly, this is point T, circle that we have here. TP and TQ are the two tangents we have drawn. Prove that PTQ, this angle, is equal to 2 times angle OPQ. Center of the circle is here O, right? PQ, let's join this angle OPQ. If we call it as theta, we need to prove that PTQ is equal to 2 theta. This is what we'll have to prove. So about doing it, it's a 3-step process. This is a diagram that we have, right? First and foremost, we know that TP is equal to TQ, right? TP is equal to TQ. From an external point, you draw two tangents. Both these tangents are equal in length, right? We said that this angle is equal to 2 theta. So if TP is equal to TQ in triangle PTQ, we can quickly say that angle TPQ is equal to angle TQP. These two angles are equal. We'll just give it a name for the moment to help us navigate through this. We'll say this is equal to an alpha. So in triangle PTQ, sum of the three interior angles is equal to 180 degrees, which is angle PTQ plus angle TPQ plus angle TQP, right? 1, 2, 3, right? All of these three angles, right? Angle TQP, angle TPQ and angle PTQ is equal to 180 degrees. PTQ is equal to 2 theta. Each of TPQ and TQP are alpha each. So alpha plus alpha is equal to 180 degrees. 2 alpha is equal to 180 degrees minus 2 theta. Divide the entire equation by a 2. So it will leave us with alpha is equal to 90 minus theta. So henceforth we will not write it as an alpha, we will just replace it with a 90 minus theta. That's what we have. Both these angles are 90 minus theta. What do we have to find out? We need to find out this angle. What do we know? This is 2 theta, and we also know this component, this angle TPQ. Angle TPQ is equal to this angle TPQ is equal to 90 minus theta. I am not writing it there because I do not want to add any more confusion, right? Now look at it, TP is a tangent and OP is a radius. So TP is perpendicular to OP is established. This angle is equal to 90 degrees. This entire angle is the sum of OPQ and QPT, right? The sum of those two angles. So we can say that angle OPT, which is equal to 90 degrees. This 90 degrees is actually sum of two angles. One is angle OPQ and the second one is angle TPQ, this angle TPQ. What did we find TPQ to be? We found TPQ to be equal to 90 minus theta. So 90 is equal to angle OPQ plus 90 minus theta. Take both these terms to the left hand side, 90 gets cancelled with 90, which translates to OPQ is equal to theta, right? This minus theta goes to the left hand side, becomes theta. So establish OPQ is equal to theta. We know PTQ is equal to 2 theta. That's the initial assumption or assignment that we did. So what have we established? OPQ is equal to 2 theta. Theta, which is 2 times theta, is equal to 2 theta. We have proved that.
Before you leave, I want you to do two things. One, sign up at online.maxtute.com to get started with CBSE Class 10 Math online tuitions. It takes all of 5 minutes and less than 3 steps to get started. And second thing, I want you to subscribe to this channel and turn on notifications so that you get notified every time a new video is uploaded. Spread the word about this channel to your friends and classmates.